everyone, and welcome to the weekly online classes for learning how to write smart contracts on Bitcoin SB with a script. So today we are going to look at what are the script context, and we are going to learn what is script context. So a script context in a simple way or an explanation. When you run a smart contract in a script, the smart contract public methods pass some arguments when you call it. So there are another type of arguments that smart contract can also see, which are the script context. So these script contexts are like properties that are under every smart contract base class. So this is what is script context. So as you can see in this diagram, we have transaction 0 and transaction 1. So this transaction 1, the first input of this transaction is depending from second output of transaction 0. Here we have 3 inputs and 3 outputs, and in the transaction 1 we have 2 inputs and 2 outputs. So the first output of the transaction 1 is pending from the second output of transaction 0. So script context can have information about the UTXO, which is the UTXO stand for unspent transaction output. So as you can see in this paragraph, it says when the second input of transaction 1, which has 2 input and 2 output, is pending the second output of what? Transaction 0, which has 3 inputs and 3 output. So the context of the smart contract in the later output is roughly the UTXO and the transaction 1, which is cycle in rate. So without wasting much of our time, I think we will go further to see what information can we get with the script context, since we said that script context is like a property in every smart contract based class. So this is the interface of script context, and it is in the doc. You can, so these are the fields, these are the information you can get with the script context, and you can access it in every public method since it is like a property, but it is prohibited to access it in non-public methods. So the first one is the version. So you can get the version of the transaction by leveraging a script context, and they are divided into 2 script context fields. The first one is the information about the UTXO. There are 4 here. From this one, UTXO.value, up to here is the information about the UTXO. This field gives you the UTXO value, means the amount of Bitcoin in the transaction, and the UTXO.script, it gives you the locking script of the UTXO, and the UTXO.outPoint, the transaction ID, it gives you the transaction ID of the transaction being spent, and also the output index give you the index of the UTXO in the outputs. So while the others are the information sending transaction information, spending transaction information, which are the version, the lock time, sequence, hash outputs, and hash previous output. But if you didn't understand it like this, so let's explain it in the contract so that it will be a good example to explain it. So let's look at this sample contract. So this is a time lock contract. The class name is the contract name is time lock, and in this time lock, this contract, what it does is that when you lock some Bitcoin, you cannot move it until a specified time has reached. That's why it is called time lock. So as you can see, we have a property here which is of data type big integer, and it is mature time, and this mature time, it is the time that will be reached for the contract to be interactive. So the time can be timestamp or block height or Unix time. And here, as you can see, we initialize it in the constructor, and we have a public method, and the name of the method is unlock. So this is where script context come to play here. So this .ctx.logTime, as I have already told you that it is a property in every smart contract base class, so we can easily access it with this, and this ctx is the context. So this .context.logTime. So logTime is a field. Let me show you. This is logTime of the transaction. So this logTime will make sure that the contract will not be interactive until the log time is reached. So this is the most common way to use script context. I hope we are together. Hello, are we together?
Yes, yes.
Yes, yes.
Okay. So let me show you another example of script context. So here is another contract, and the name of this contract is designated receivers, and what this contract do is just to send 1000 satoshis to two people, which in this case are Alice and Bob. So we have two properties, which the first one take Alice public key hash, and this public key hash is a domain specific type. You can use this pub key hash where you are expecting byte string. So this public key hash is a Bitcoin address. Is a hash version of the public key, this pub key hash. So we got the pub key hash of Alice, pub key hash of Bob, and we pass them to the constructor, we initialize them, and this is the public method that handle the sending of the satoshis to these people. So the first output is the Alice output, and the output is of data type byte string, and this utils is a standard library in the built-ins. Maybe we'll talk it later in our next class. This is built-ins. It is here, this public key hash output. It construct a pet public key hash output for sending satoshis. So, and it takes two parameters. The first parameters is public key hash, and the second one is the amount of satoshis to be sent to this public key hash. So this is the amount of satoshis to be sent to this public key hash. So here we are saying that this output will send 1000 satoshis to Alice, and also Bob output will send 1000 satoshis to Bob. So we have two outputs, Alice and Bob outputs, and our output is Alice output plus Bob output. So the output of this contract is Alice output and Bob output, and we are having two outputs actually. So we also handle the change output. If we have a change, we can handle it in the build change output, and by default it will use this change output to send it to the signer's address by default. So let me show you where the script context come to play in this contract. This .ctx.hash outputs is a hash outputs is a double SHA-256 of all the outputs. So it is making sure that the output are actually from the pending transaction as expected. So this is outputs from our contract. Hash 256, this output is this one, this variable output is here. So we double SHA-256 the outputs and make sure that it is the same as the pending transaction from the context. So this the CTX, the hash outputs, make sure that the transaction from the contract and transaction from the context is the same. The hash output must be matched. So these are some simple example of how we can leverage script context, and we have hash previous output and the seek hash type. And this seek hash type is a topic of itself, so we will talk about it later. And for this script context, and I think this is what we have for the script context, and if you need more explanation, you can directly come to our documentation at docs.script.io. Under the how to write a contract tab, you will see the script context. If you click on the script context, you will get more explanation, and there are many resourceful links to understand how script context actually work and how we can leverage script context to do many things. For example, we can maintain state by leveraging script context and many things. So I hope you understand what script context is, and if you have any question, please